In this part of the module, we will talk about Y and delta networks and how we convert one form to the other. So let's say we convert a Y network to a delta network and vice versa. Let's say we have this problem and our task here is to determine the voltage across the 35 ohms and the current that comes out of the 100 volt source. So the first instinct would probably be to um, solve for the equivalent resistance of this network of resistors. And to do that, uh, we would need to identify what are those resistances that are in series and in parallel. So we'll proceed by identifying the nodes of the circuit. So this is one node here. This is another node. This is another node. This one and this one. Okay. Uh, and we notice that there there seems to be no resistances that are in series and or in parallel. So let's take, for example, the 10 ohms and the 20 ohms. Well, they are connected to this node. However, they don't share it exclusively because the 30 ohms is also connected there. So therefore, they cannot be considered in series. Uh, 10 ohms is not also in series with 15 because 12 is connected to this node. 10 or 15 is not in parallel with 30 because both elements are not connected to the same nodes. Although 15 and 30 are connected to this node, on the other side, they're not connected to the same node. So 15 is connected on its right to this node, while 30 ohms is connected to this node. So therefore, they're not in parallel. So there's no group of resistors here that we can uh, group together and simplify the circuit um, that will lead us to replace the whole circuit into an equivalent resistance. So what are we going to do about this? To solve the previous circuit or problem, first we need to recognize a Y or a delta network. So for example, if we see something like this in a circuit, uh, that part of the circuit forms a what we call a Y network, or sometimes we call it also a T network because if we arrange the resistances, it would look like a letter T. Also, if we see something like this, we call this a delta network, or sometimes we call it a pi network. So a Y or a delta network can be converted from one form or the other. So let's say we have a delta network that can be converted into a Y network, or a Y network converted back to a delta network. So let's deal first with the delta to Y conversion. Let's say we have a delta network and we want to convert it to a Y network. So the first thing that uh, we can do is we can superimpose the Y network inside the delta network. So this is the delta network. The resistances are labeled R1, R2, and R3. And we need to solve for those resistances. So the formula is given here. So there is some pattern on the formula. For example, we will notice that the denominator is simply the sum of the resistances of the delta network, the network that we want to convert into a Y network, and then the numerators are or is the product of the resistances in the delta network that is adjacent to the resistance that we want to solve for. So for example, we want to solve R1, the numerator is the product of the resistance that is adjacent to R1, and these are R sub C and R sub B. Same for R sub 2. So the numerator in the formula is the product of the resistances adjacent to it. So this is the resistance R sub C and R sub A. And likewise for R sub 3, the adjacent resistances are R sub A, this one, and R sub B. So that goes in here. Now for Y to delta conversion, so we're given the Y, and we also superimpose the delta. So now what we're trying to get are the resistances R sub A, R sub B, and R sub C. So this is the formula. And again, there is a pattern on this formula. So for example, if we want to get R sub A, uh, we notice that the denominator is the denominator is simply the resistance facing the resistance R sub A, or that is in front of resistance R sub A, which is R sub 1. For R sub B, its denominator is the resistance directly in front of it, which is R sub 2, and R sub 3, or R sub C, it's R sub 3. Okay. Now for the numerator, it is simply the sum of the product of the resistances in the Y network taken two at a time. So R1, R2 plus R2, R3, R3, R1. And the numerator for each of these are just the same. So that is the formula for the Y to delta conversion. So let's go back to the original circuit, and to do the conversion, we need to identify the parts of the circuit that is a delta or a Y. So for example, this part here is a Y or the T network, and that can be converted into something like this, or this one. That is a delta network. So remember, a delta network is a network that is an enclosed that encloses a path. So this is an enclosed path. So that can be converted into something like that. So let's use these conversions. So the T network previously there is replaced by a delta network. And what's good about this conversion is that this, once it is converted, we can see that these two resistances are in parallel. these are also in parallel, and also this one. Okay, so they can be combined to form a much simpler circuit. So let's do that. So let's superimpose the um, delta network that we're trying to determine to the original circuit, and solve for these resistances. So this is the solution. So first, let's solve for R sub C. We notice that in front of R sub C is 12 ohms, so therefore that is R sub C. So the denominator is the resistance in front of it. Now the denominator for R sub B, the resistance in front of it is this one, the 10 ohms, and for R sub A, it is the 15 ohms. So solving for them would yield this result. So using these values, this is now our new circuit. So now we can combine the resistances, because if we, for example, identify the nodes, so these are the new nodes now, this one and this one as well. So we notice that 30 and 20 are in parallel, 30, 37.5 parallel, 35 and 45 parallel. So we simplify those, we combine those, and that will give us a circuit that looks like this. Okay, and for this simplified network, we notice this is obviously in series, and the combination is in parallel with this one, so we can combine them into this and finally solve for the current and the voltage. As an exercise, you could probably try to convert this part of the circuit, which we said before is a delta, into a Y network, and also solve for the voltage and the current, um, just to verify the results that we got earlier. On our next video, we will proceed to the basic laws in circuit analysis, and these are the Kirchhoff's current law and the Kirchhoff's voltage laws.